Hello out there to you. Let's do some examples of elasticity. This is called arc elasticity, where I'm trying to calculate the elasticity of going from one point to another. And it's actually going to change as I go along the demand curve. So really, I'm just doing calculations, okay? So let's get some things out of the way here. So price elasticity of demand as a formula is going to be the percent change in the quantity demanded divided by the percent change in price. Now, if I want the percent change, then I want the new value minus the old value. And then I could just do divided by the old value, but typically we're going to do the midpoint, which is the midway in between these two. And then we're going to multiply that by 100 to get us a percent. Okay, so this is a percent change. And so if you wanted the midpoint, you could go new plus old divided by 2. It's really just averaging the two, and that'll give you whatever the midpoint is. Okay, on these you can likely do in your head. So I'm going to make a little table here. I want to go from A to B, B to C, C to D, and D to E. So let's make a little table here. Let's make quantity. I'm going to do quantity first. Make this a little bit bigger here. Quantity demanded, and then price. Okay. So for the first one, the quantity demanded is 40, and then the price is 80. Okay. I'm doing it this way because quantity is on the top, so there's no real rhyme or reason. If you don't like that, then don't do it that way. Okay, so then the next point is point B. Point B has a 60 quantity and the price is 70. And then point C is going to be price of 60 and quantity of 80. Okay, I need to make that 36 also. And then now we're going down to point D. Point D is 120, and the price is 40. And then quantity demand is 180 for point E, and the price would be 10. Okay, so now I've got all my numbers there that I can use to calculate. Okay, so let's try to type this first one here. Okay, so the first one I want to know, I want to go from here to here and know what the elasticity is. Now the nice thing about using the midpoint method is it doesn't matter whether I'm going up or down. Okay. Now you'll always get price elasticity of demand is always going to be a negative number. Typically we report this in absolute terms. So it's a negative number, but then it's in absolute, so you'll hear people say it's a positive number. So we've got A to B. Okay, so at A, point A, we've got a quantity demanded of 40, and then we're going to the new one. The new one's actually 60, so 60 minus 40 is the numerator, and then we want to divide by the midpoint between those two, and the midpoint is 50. You can just calculate that. Okay, and then we're going to divide all of that by the change in price, which is going to be 70 minus 80, and then divided by halfway in between there is 75. So let me put some that, and that. And both of these are multiplied by 100. So we get a percent and a percent. Really, these cancel out, so it's not that big a deal. All right, so this is 20 over 50, and 20 over 50, just to save us some time, is 0.4 anyway, but 20 over 50 is 0.4, which is 40%. So a 40% change in the quantity. And then down here, we have 10 over 75, which is 13 1/3%, and so then you just take 40 divided by 13.3, and you get right around 3. So the elasticity changing from point A to point B is 3. Okay, so that was the first elasticity, and that was going from A to B. Okay, now, because this was point A, and this was point B, C, D, and E. Okay, so let's now do B to C. So B to C, we're going, new quantity would be 80 minus 60 over 70, again times 100, divided by the change in price. Okay, so this would be 60 minus 70 over 65 times 100. Figure out what this is. And okay, so that's 20 over 70, so 2 over 7 is 28.5. It's okay to round these because this is all, of course, a ratio. Okay, and then 10 over 65 is 15.3%. And then I go 28.5 divided by 15.3, and I get like 1.86. Okay, so 1.86. Okay, so now both of these are above 1, so that means they're both elastic. Okay, so this was B to C. Okay, both elastic so far. Okay, now let's move down a little bit. And now we want to go from C to D. So from C to D, getting the hang of this, it's 120 minus 80. It's really just the difference, divided by halfway in between that, which is 100, okay, times 100. And that's the percent change in quantity. And then divided by the change in price. So this will be 40 minus 60 over 50 times 100. So now we've got 40 over 100. Okay, so on the numerator down there, because that's 40 divided by 100, which is 0.4. And then right here, this is a difference of 20. So 20 divided by 50, which is also 0.4. So this turns out to be 40% divided by 40%, which is 1. And well, it's -1, but in absolute terms, it's 1. So this is unit elastic. So this point is unit elastic, or rather, that change is unit elastic. So the same change in quantity is the same change in price, and vice versa. Okay. Last one. This is D to E. Okay, so D to E, and we're going to go 180 minus 120. Okay, so we're going down here, and then halfway there would be 150 times 100, all divided by 10 minus 40 over 25 times 100. And we're going to go, okay, so up here, this is a difference of 60. So 60 divided by 150 is 0.4. Man, I really like that 40% on this one. And that's okay. So 40%. 40% change. And then down here, it is 30, because that's the difference on the top. 30 over 25 over 1.2. That's a big change there. So 120%. And 40 divided by 120 is 1/3, or we would say this is 0.33. Okay, so this one is less than 1. So this one is inelastic. Elastic. And this one was unit elastic. And this one was elastic. And this one was really elastic. Okay, so what this means effectively is in this scenario, the consumer cares a lot about the price, care a bit about the price. This one, it's going to dictate their behavior, and then this one, they care the least amount. Okay, so those are some examples on how to calculate price elasticity of demand.